All right, we are live on YouTube and we are recording. Shar and Vipin, take it away.
Thank you, Sean. Awesome. I'll start with some working group updates and then pass it over to you, Vipin, for the presentation. Um, Welcome to the Identity Special Interest Group for December 12th, 2024. Um, we are following the Linux Foundation antitrust policy as usual, as well as the code of conduct, which are written and linked here. We're recording the call and it will be posted right here later today. If you'd like to put your name on the attendees list, that would be great. And I'll send out this wiki link. Oh, thank you, Sean. Beat me to it. Awesome. So yeah, if you'd like to put your name on there, that would be great. Let's see. Do we have any announcements, or would anybody like to hop off mute and introduce themselves to the group before we begin? All right. Just a quick note that the next meeting in 2 weeks will be canceled for winter holidays. And we will post about upcoming meetings in the new year on the Discord and email list. So let's see. Unless anybody has any other announcements or anything to bring to the group, I will jump into our working group status updates. I'll go quickly through so that we have plenty of time for the presentation and discussion, but feel free to jump in with any updates on working groups that you are involved in. So we'll start with the Open Wallet Foundation in Aries Cloud Agent Python. Release candidate 1.1.2 is out. There was an issue with linked data VCs that is being fixed. We also discussed multi-tenant OpenID for VC. We had a demo of the PyIdentity wallet, and then a bit of discussion on the Bitstring status list plugin. On Credo, let's see. They are discussing the key management system. They have a new key management API to allow easier separation between crypto and storage features. And let's see, if you want a, a big picture overview of what Credo has been up to in the last year and their goals for 2025. Last week, they were on the wallet interoperability SIG, and Timo gave a great overview of that. So definitely check that out if you want more details there. Let's see, Bifold and Owl. I haven't been able to find more recent meeting notes, but it does look like for Owl that they're planning ahead towards January, and we'll talk about the mobile wallet test harness, Owl Akrita, as well as other topics. Oh, Sean, you have your hand up.
Yeah, the Bifold team most recently, they're working on OpenID, OpenID plugin for Bifold, which OpenID connectors for Bifold, which is pretty exciting. Also, the Credo team won the ID Next Innovation Award last week. Unfortunately, I wrote a blog post about it and then forgot to include it here on the ID SIG. So I'm sorry, Shar. I'll add it into the wiki in a second. I'm also going to post it to the chat here on Zoom in a second. But thank you. And for anyone who wants to see a fantastic wallet interop SIG, the Credo team and Shar obviously and everybody else at the OWF who's working on this stuff did a great job. It is absolutely worth watching. It's a great video. Sorry, Shar, you're
Yeah,
back.
absolutely. No, thank you. And just Sean, while we're talking about it, so there was the event yesterday with the Sprint Funke Challenge.
Yes.
Um, and I'm looking on an announcement on LinkedIn, and it looks like Animo Solutions and Ubik, I'm not sure exactly how to pronounce that, are the ones that have advanced.
Yes,
So to the next stage.
they've both advanced to the next stage, which is super exciting. I don't know the Ubik team, and I agree with you, Shar. I'm not sure how to pronounce it. I got to look that up. But also, I believe the Lisi team also moved on, which is really exciting. So that
Awesome.
I'll find a link to it and I'll put it here in chat as well. The Funky Challenge is really exciting. the German government has an innovation team, and they've been doing a competition around EU digital identity wallets, and it's really been exciting to watch the teams and the work that's gone into it. That's a great call out. Thanks, Shar.
Yeah, absolutely. Super exciting. Yeah, if you have a link, I can add it to the meeting page. Let's see, on the wallet interop SIG, we met yesterday, had a great presentation and discussion on batch issuance, unlinkability without ZKPs. It was, yeah, super interesting to go into the two different approaches of using a single credential that can be used everywhere, which is then correlatable across verifiers, versus batch issuance, where you get a bunch of the same credential that you can use everywhere, and verifiers can't correlate it, but that just adds wallet and issuer complexity. So that was great to hear about. On a non-creds, looks like they're talking about revocation scheme design, revocation manager, non-creds BBS. Let's see, in the indie contributors working group on our last call, we had a presentation and demo from Brian Ellie, who was the Hyperledger mentorship program mentee, who created an indie read replica. So that was also great to see. Let's see, in the Trust Over IP Foundation, as far as I could tell, this October meeting was the last all members meeting, but if I'm mistaken about that, feel free to correct me. Let's see, on the governance stack working group, let's see, they did a recap of the IW session on first person credentials and how a governance framework for this new social proof of personhood might evolve in terms of an ecosystem. Oh, and thanks for sending that link, Sean. Let's see, in the technology stack working group, they've got all their different task forces. I won't go into too much detail, but here's just a quick overview, reports from each task force on what they are doing. So you can click the links for more details. Concepts and terminology is working on the main TYP glossary. Let's see, in the Decentralized Identity Foundation, there is, let's see, I wasn't able to find more recent DIDCOM spec working group meetings, but there's a lot going on in the DIDCOM users group today, right now. In fact, they're having a DIDCOM interopathon. This will focus on testing DIDCOM v2 features. The goal is to facilitate scenarios like sending a message from one app to another where the receiving app decrypts and understands the content. So yeah, super excited to hear how that goes and what they learned from it. Let's see, Trusted Web Working Group, I need to update that title because the new name for this work is DidWeb VH, VH for Verifiable History. Let's see, they've got a new version of the spec that is linked here. It sounds like the next efforts are updating the implementations to this new version and try to maintain backwards compatibility where possible. Let's see, in terms of the IoT special interest group, don't believe they have been meeting more recently, but let me know if I am not finding their meeting notes in the right place. In the W3C, they had their community credentials call this week. Let's see. Yeah, that was a quick overview of what's going on across the different groups that we track. Are there any details that anybody would like to add or additional groups anybody would like to report on? Great. With that, I will pass it over to you, Vipin, for your presentation.
Thank you, Shah. And thanks, everyone. We have already gone through all the administrative notes, so I'm going to share my screen. It'll take a
Sorry,
second, I
Vipin,
guess.
I don't know if it's just me, but the audio is really quiet. Is anybody else experiencing that?
Yeah, I heard that from Sean. So I'm
Okay,
going to speak up a little bit.
thank you. Awesome.
If it does, um, I hope you guys can hear me now,
Great, thank
right?
you.
So I'm going to share the screen and turn it into a slideshow.
Looking good, Vipin.
You can see it. Antitrust, all the stuff we already went through. So this is a rough sketch of the agenda. Why, how, then the niche standards, and then open source libraries. The main thrust of this presentation is to go towards implementation of the post-quantum landscape, or as they call it these days, it's quantum safe landscape. Then, we go through some of the challenges in cryptocurrencies and general blockchains, and then financial infrastructure impact with the payments, and also experiments conducted by the BIS. And then, of course, open Q&A and open source discussion. So to set I'm not going to go into why PQC, what is quantum computing. I'm only going to talk about the reason that quantum computing is going to challenge the existing cryptography. And furthermore, also to talk about the fact that even though you're not a believer in the arrival of quantum in the next decade or two, why it is important for us to start transitioning into PQC. So the background is that Shor's algorithm, which is going to break RSA, ECDSA, ECC, etc., because it is going to create polynomial time breaking time for integer factorization and logarithmic factorization. The other algorithm that is important is Grover's algorithm. It's reducing the time for quantum search, but still, they are relatively safe. The symmetric keys and hashing algorithms are relatively safe. Just doubling the size of the hash will hold Grover's algorithm at bay. But all these reasons, we see that our current cryptographic ecosystem is vulnerable. And for a deep dive into quantum algorithms, you can look at the algorithm Zoo, which has got a huge number, a list of various algorithms, and Shor's and Grover's, of course, being the key ones. Why is PQC needed? Here, HNDL is harvest now, decrypt later. That means people are already storing encrypted data in the hopes that there will be a future availability of quantum computers that will help them break it. So for vulnerable data, it is very important, whether you believe in the quantum computing or not, to talk about transitioning to PQC. this is a short digression into how distant is Q day, or the day that those quantum algorithms, those cryptographic algorithms are going to be broken. Well, it depends. Um, and It definitely lacks scale at this point to break current cryptography. In fact, it's pretty anemic. The main problem is quantum decoherence, which introduces errors. And this is not an engineering problem, it is a basic physics problem. Quantum qubits are always on the verge of decoherence. And they are very transient, in the order of nanoseconds, or sometimes they have stretched it to hundreds of microseconds. And we are in the noisy intermediate scale quantum era. And some people say, no, we have already transitioned beyond noisy intermediate scale quantum. I contend that we are not even in the noisy intermediate scale quantum, but we are in the noisy micro scale quantum. But of course, the guys who are working on quantum computers are always producing a lot of hype, and everybody echoes them. And one of the main, one of the huge pieces of news lately has been, actually it came out on the, 2 days ago, advances in error correction by the Willow chip, done using Google. And there's a paper on arXiv, which has been around for a long time. So basically, the error correction is done by the following means: that you have hundreds of qubits that follow regular error correction methodology, which is produce results from all of these and then take an average, or some kind of a, some kind of an approximation to every result. There is Scott Aronson, who's a very well-known quantum researcher, has said that he's a skeptic because he knows the field quite well, but he is slowly getting converted to the possibility of the arrival of quantum computing in the next decade or so. In short, the Willow thing is a good thing. It shows real advances in error correction, but it uses something called RCS, random circuit sampling, which cannot be verified using classical computers, because that is the whole point of a quantum computer. They claim that it'll take a classical computer some 10 septillion years, which is longer than the age of the universe, to verify this. So you produce a result that cannot be verified by any other means. Of course, people are not going to just say, yes, this is quantum supremacy. So why PQC? Because, of course, the Handel problem, which is harvest now, decrypt later. What happens if quantum computing becomes a reality in the next 5 years? I mean, some people are predicting 5 years, but no matter what, we are not sages or seers. We cannot see into the future, so it is better to be safe than sorry. So we go back to the abelian groups concept for sure. So how do you get out of, how do you create a post-quantum cryptography. We have to go back to our high school algebra. Abelian group sounds very technically dense, but it's very simple because we are familiar with these concepts: associativity, identity element, inverse element, commutativity. These are taught in high school algebra. So if a group follows all of these, then it is an abelian group. The group of real numbers, integers, all of these follow, all of these are abelian groups. So how do you get out of this? You constrain it, just like in regular mathematics. You say, how do you get from Euclidean geometry into some other form of geometry? You start constraining the axioms. So here the axiom that is constrained is the commutativity, because if A operation B is not equal to B operation A, then it's not a abelian group. And that's what most of the ways in which PQC works, which is create a non-abelian or a group that does not have all of these properties and just have the first three, for example. But unfortunately for us, the RSA algorithm is based on integer logic, and the elliptic curve stuff that it secures a lot of different ecosystems, just like Bitcoin and others are vulnerable because that's also an abelian group, the Euclidean, the elliptic curve based groups. So these are, some of the approaches. I'm not going to go into details on any one of them or even any of them, because some of them are highly mathematical, but just look at them. There are only two algorithms needed. One is a key encapsulation method, just like what is used in Diffie-Hellman key exchanges, and a digital signature algorithm. So there are only three NIST standards established for PQC. One is based on the lattice keys, a lattice-based cryptography. The other is a hash-based cryptography. Now I get into a reason why people have chosen to implement things the way they do. I'll get into detail in a minute, but because when we look at the implementations, we can see that they use a hybrid approach. So the Diffie-Hellman key exchange, as you know, is a way of deriving a symmetric key through a set of exchanges where the symmetric key itself is never sent in a message. It is always using the public key. Bob's public key is known by Alice, and then she sends through the keygen process an encapsulation to Bob, and Bob does an encap, and he creates a key called K, and he then also, the result of the encaps which is not the key, is a ciphertext sent to Alice, which then calls a decaps function, and Alice gets K prime. But the main thing to note here is that K and K prime are the same. So now they have magically, they have K and K prime, which are symmetric keys that they will use in their subsequent message exchanges. This is the establishment of a symmetric key. Later, that key will be used in exchanges. Oh, okay, sorry. So the KEM FIPS 203 is for the key exchange mechanism, and FIPS 204 is the DSA. ML here means module lattice based. So the 203 and 204 are based on module lattices, and 205 is secure hash based DSA, digital signature algorithm. I cannot go into the details of PQC standards right now, but because it would take for each one of these a long time. But note one thing, that NIST has come up with a bunch of implementation guidelines which have to be followed. So there are two things that NIST came out with. A bunch of implementation guidelines for implementing FIPS 203, 204, and 205. The main ones are that internal functions should never be exposed outside. Keys should never be in the clear, inside the code, even inside, encryption and everything else have to happen. And the keys are to be, if there are intermediate results created, they should be thrown away. All standard cryptographic practice, but NIST has come out with that. The second thing that NIST has done is they have created a guideline or something for any enterprise to transition to the PQC. That is more an operational sort of guideline, which is to do a survey of your own vulnerabilities, your own cryptography, and come up with a plan to transition them slowly, bit by bit, because the adoption of a single new cryptographic standard will take 10 to 20 years for any for the organizations to adopt them at scale, unless two things happen. One is an awareness of cryptographic agility. The second is the possibility that PQ quantum is really here. Some of the problems with this post-quantum stuff, the chat seems to have more messages there. I cannot read them. So if anybody wants to tell me what they are, I can, and if they are urgent, I can.
No, keep going, Vipin. Somebody requested something from me. It's all good. Keep going.
All right. So this is the landscape that we are in right now. So the other part is the availability of open source libraries and frameworks, because without these, we cannot implement them at scale inside enterprises. We need hardened cryptographic libraries that follow the standards. And this open source PQC Alliance is actually incubated by the Linux Foundation. So it's called LibOQS. and I have the GitHub also linked in here. There is a framework from Google called Tink, which is already a framework for other cryptographic libraries. They're going to expand it into the Tink, into using Tink. So the way Tink protects you is that you make those same calls like ncaps, decaps, and all that, and keygen, and the Tink can switch out the algorithms underneath that implement these functions. Now, the actual implementation, we go into this thing called the double ratchet, which is used by Signal and many other protocols. So the double ratchet is an interesting protocol because it is happening when we use Signal today. We are not even aware of it. So this is the secret, that the users should not be involved in the details of the cryptography. It should just work right out of the box. Signal is using double ratchet. Double ratchet is a ratchet on the Diffie-Hellman root key. That's a single ratchet. The other ratchet is on the symmetric key itself. That keeps on advancing into the future. That's why it's called a ratchet, because the ratchet goes only in one direction. As you can see from the illustration on your right, the ratchet is a mechanical wheel that can only rotate, in this case, in the anti-clockwise direction. It cannot rotate the other way. So the double ratchet constantly moves the key forward, which means that just compromising one of the symmetric keys or one of the root keys will not compromise the entire exchange, will not compromise the private key of the DHKE stuff. And this is an illustration of the double ratchet algorithm from the original paper in Signal, written in 2014, somewhere around there. And Moxie Molenspike is the author. Of course, it's not a real name. Moxie Molenspike sounds too suspicious. They have gone to post-quantum for one part, which is the establishment of the Diffie-Hellman exchange. It's called PQDXH. Post-quantum extended Diffie-Hellman. So only the DH ratchet is covered by the hybrid approach. Now, what you may ask, what is a hybrid approach? The hybrid approach is needed because post-quantum algorithms are still new. In fact, in the evaluation conducted by NIST and the candidates that were submitted for approval, the post-quantum, the PQC algorithm, one of the methods was broken in a week and on a laptop. So you can imagine that these post-quantum computing algorithms have not been hardened sufficiently. So what is a cryptographer to do? They are saying, use a hybrid approach, which means use both current ECDSA or RSA or AES for whatever exchanges you have, current Diffie-Hellman key exchange, And on top of that, use the post-quantum algorithms to do the different types of cryptography that you do, which is, in this case, it's the post-quantum extended Diffie-Hellman key exchange. In Signal, Signal is, of course, the leader. And why is this important? Because messaging is a way to secure your assets, your private messages in flight, and which is very important if you think about TLS, HTTPS, everything that we do today, like sending messages or using Zoom to have a private conversation. If somebody breaks in and decrypts that, then they can get a lot of information from that, which they can use to either attack you or to discredit you or do all kinds of things, or inject their own um, fake messages into the conversation. So messaging is the ground level. And why is PQC important for the identity working group? Because everything that helps to preserve our identity is based on cryptography. And if that gets broken, then we have a real problem in being private and being individuals and being, talking about things that concern us and freedom of speech and so on and so forth. Of course, the other flip side of the coin is using these private methods of communication to collude or to create a pathway for fraudsters or something else. Anyway, so hybrid is the way to go. So we talked about two things. One is, why is post-quantum being deployed right now, even though quantum is probably decades away, and in my opinion, even further than that. But that opinion and $2.90 will get you on the subway. This, in other words, it's worthless, right? Because it's only an opinion, but it's a considered and scientific opinion. Even a lot of other people share that opinion, but we still have to be ready for the future, whatever way it might come up. And that's why we need PQC now and a plan to get to PQC now. Second is the fact that quantum algorithms are not proven battle hardened, so we need a hybrid approach. Of course, naturally, the question is, what is the cost, right? I mean, what are the key sizes? How much time will it add to the message exchange? They've already, that is an engineering problem, meaning you can make it faster through a variety of means. And they have already proven that if messaging, which is almost instantaneous, can be secured with a hybrid approach, then other latency-ridden processes can also be secured. This is PQ3, which is Apple's version of iMessage, is already at scale, deployed at scale, because as you can imagine, iMessage is definitely used by billions of people, if not, if not millions, at least hundreds of millions of people. And they have gone to what they call level 3, which is basically the hybrid approach taken to the symmetric key ratchet. So the symmetric keys rekeying is key establishment and rekeying, that the second part of the double ratchet. So we are already demonstrated that PQC can be used at scale. And now we come to Bitcoin and PQC. So these are the various ways in which payment script operate. P2PK, which is paid to public key, which is meant to be obsolete, but still 1.7 million BTC supply is secured using that, which means the coins that Satoshi, for example, mined have not moved, and they are P2PK. And they are extremely vulnerable, and this is why I've chosen the color red there. The others are a little more secure, more secure. P2PKH is paid to public key hash. That means that public key is not known, it's not in the clear, only when you're making the payment and it goes into the what do you call it, the into the temporary store for the miners to consider for inclusion in the blockchain. Do we know the public key? So the same thing for the script hash and the witness public key hash and the witness script hash. But even if, and paid to Taproot, which is the latest, a very low volume. So we see that 10% is definitely at risk. And if 10% of Bitcoin is being hacked, then the whole value of Bitcoin will fall like crazy. And there is no doubt about that, because so people have already started doing something about it. There is a existing project called Bitcoin PQ, but it's based on older versions of PQC. Hard forks are needed, and extended Merkle secure hash functions. Extended Merkle hashing is used instead of ECDSA, which is not ideal. And I have a suggestion: is try to create a fork of Bitcoin and use a hybrid approach for all Bitcoin, and extend the size of the hashing algorithm to protect against Grover's function. If these two things are done today, then we can have a better security. Plus, we'll be able to see what the effects are, right? We'll be able to see how much latency does it introduce, what can we do to protect the Bitcoin for which the private keys are either lost or the owners are dead or the owners have not appeared, which is 10% of the 10% of the Bitcoin. In Ethereum, I spoke to Justin Drake just recently, like last week, or was it the week before? Time flies. And we spoke about the Bean chain stuff. And he wasn't aware of Bitcoin PQ and about the niceties of the NIST algorithms. And I said, you guys have to do this to harden Ethereum through PQC. Luckily, Ethereum is a very active ecosystem. Plus, Ethereum secures huge amounts of L2s and other, financial DeFi and other products that are transforming finance. And these three items are the key items that Beam Chain from Justin Drake. And also Beam Chain, the name may change because there are some problems with the name. But in any case, it is the future roadmap of Ethereum. Vitalik has written extensively about it. And Justin Drake goes around proselytizing this. He's a great guy. The Ethereum Foundation is filled with very interesting people, many from Cambridge, mathematicians, and others. They also have a initiative to do formal proofs of smart contracts, which will reduce bugs and prove that the smart contract does what it's supposed to do mathematically. And this is a $20 million effort led by a single guy, it's Alex. So, they have money and they have great guys working on everything. So my bet is on Ethereum for that. But, Bitcoin seems to have grabbed all the oxygen in the room right now, but Ethereum is where the future of finance is happening. Now we get into the payments landscape. And as you can see, this is called the four corners model, and there are two types of encryption here. The network, the party originating, party receiving, and the other banks involved, and also the data at rest. So all of these, the data at rest and the data being exchanged through messages, have to follow the hybrid model. Otherwise, it's not going to work. This is from a paper that I have referred to, I have quoted in the end references. This is a look at the finance project called LEAP, which is also using the hybrid mode. And it is sponsored by the by BIS, and the two parties here are the Banque de France and the Deutsche Bank, and they are trying to create a hybrid messaging platform between these two entities, right? That is a great effort, and you can see the results in the BIS paper. LEAP paper. Now we come to the last bit, which is fully homomorphic encryption, which is a very important privacy preserving activity, cryptographic ecosystem. It is already based on lattice, so it could be PQC or PQS, that quantum safe. ZKP work is ongoing. Depending on the hashing functions, depending on the various things that are used, like starts and so on, they may already be post-quantum safe. And this brings us to the end of the presentation with the references. And I will fill out some more references. Unfortunately, it has been a whirlwind tour, and Sean has raised his hand. So,
Hey, Vipin, thank you. This was a really solid presentation. I can't thank you enough for it. If you get a chance and you're okay to share the deck, we'd love to put it in the wiki page for this meeting. Recently, I was at the Fides event. They did a wallet event in the Netherlands in early November, and one of the speakers from Forkbomb, Aromil, really he was doing a roast of the EUDI wallet ARF, and one of his slides was, if we do not address post-quantum, we're doomed. No, I'm going to use the word doomed. Wrong word, doomed. But he said post-quantum is
doomed is correct, because no
well,
one
his
can
speech was
predict the
the
future.
biggest threat to the space that's out there, and people aren't talking about it nearly enough. So this is incredibly timely.
So hopefully I'll be able to get some of these results or a version of this talk into the your calendar, because I don't think enough people are on this chat, on this Zoom call, but I think as I refine this further, maybe we can disseminate it more, not just as a slide deck, but also more comprehensive presentation. Anyway, any other questions? I did see some chat notes, but I didn't look at what they actually said, because I'm doing all this on a laptop. So
You're actually giving the presentation. You can't watch the chat. So Vipin, in the chat, I put some of the PCQA, PQCA links, like to the GitHub, to the Discord for PQCA at the Linux Foundation, and I believe the website as well. That was the stuff I was putting in chat. So you didn't miss anything. There were a couple of folks that thank you though in the last minute or two.
great. So if anybody has any specific questions, I'm willing to answer them in the next couple of minutes. Otherwise, we can close the call, or I can keep going for a little bit longer. I normally want to give people a chance to respond.
Yeah, I had a quick question. I was wondering if you could give a brief explanation of quantum decoherence, as you talked about in the beginning.
Well, the whole problem with quantum is the fact that these observations have been done. I mean, first of all, the theory, let's say, far outstrips the practice, right? In 1920, I think, or even before, when quantum was predicted, and there was a solid evidence of this, the observations were of these qubits in an ephemeral setting. That means when you're, they degrade fast because the decoherence is a result of the quantum particles returning to a lower energy state, basically. And in all physics, that is the fact. So in order to keep them from entering a lower energy state, what you just have to do is to reduce the temperatures. In fact, most of these quantum computers work at 4 degree Kelvin, which is minus 270 or minus 270 degrees centigrade, or minus 269 degrees centigrade. Anyway, so the way that the computers are set up, it's always dipped in liquid nitrogen. They have a whole bunch of methods to keep the quantum particles from disappearing, essentially.
Okay.
So that is, that's a layman's explanation of decoherence. I am not a quantum scientist, but we did learn Schrodinger's equation. I did learn Schrodinger's equation, but that was back in 1978. So I haven't reacquainted myself with that.
Right.
With that equation.
Yeah, cool. No, thank you for that overview. That was helpful.
78. That is a long time ago. So that's why the theory outstrips practice.
I see.
But so Scott Aronson says theory outstrips practice for quantum, and for AI, practice outstrips theory. So,
Right.
so we have these two major sort of scientific advances, each one having its own signature or characteristic.
Right. Yeah, that's an
Anyway.
interesting way to think about it.
Anyway, we are at 12 o'clock. So if nobody else has anything else, I would like to stop talking because I feel like I've talked enough.
Awesome. Thank you so much, Vipin. This was really interesting. Really appreciate this deep dive. And yeah, as we said, the next meeting in 2 weeks will be canceled, and we will post on Discord and the email list about future calls in the new year. So thank you so much, everyone, for joining. Thank you so much, Vipin, for your time and for the presentation, and have a good rest of your day, everyone.
Thank you.
Thanks, everyone. Happy New
Thank
Year.
you. Happy New Year. Bye.